Today we are diving into practical reviews of network inspection tools for Android. We will debug HTTP requests and delve into the pros and cons of each tool. Here is what we will cover. Android Studio built-in network inspector. An integrated tool within Android Studio for monitoring network activity. OkHttp Logging Interceptor. A library for logging HTTP requests and responses. OkHttpProfiler, a plugin for Android Studio for profiling and inspecting network calls. Proxy, a desktop proxy application for Mac, Linux and Windows. Flipper, an application for debugging from Meta company. Proxyman, one more desktop proxy application. And Checker, an Android application for inspecting network requests directly on your phone. So, let's start with Android Studio Network Inspector. I've prepared a single activity, single button application. And you can find only main activity class. And as we can see, it has OkHttp client on top of it. Also, it has retrofit for convenience and one service. This service will make a call, and it's a get call for a JSON file that placed in the same project. We can find colors.json here, and basically it's a map of arrays of integers. We'll parse it to map, key will be string, and value will be list of integers. And we have make request method, which will calculate current time and will make a request and then update our UI and set milliseconds of request. As we can see, on each press it updates the UI. You don't need to install anything on your laptop. You can just press View tool window and then App Inspection. Or you can double press on Shift and select App Inspection there. Just type in. And it will open the tool window and you can select your application. After like a few seconds it will show App Inspection. You can see network inspection, database inspection and background task. On each network request, new item will appear in the list. We can see color.json that was requested by click. On the right side of this tool window we can see several tabs. The first one is Overview. It contains overall information about our request. The second tab is Response. It has headers in the upper part and body in the lower part. The third tab is Request. It has same headers and body structure. Last but not least, the Call Stack tab. It has useful information about threads and methods from which the request was done. We can make several more calls and we can see that all of them appears in this list. As usual, the Network Inspector tool has upsides and downsides. Positives are native implementation from the Google team. It doesn't require any additional libraries or software. It can display API requests and static, like pictures, and it provides timings. It also provides network speed and usage. It has a call stack and threads. Last but definitely not least, you can override request or response data or code in the Rules tab. It's really handy when you need to test different failure scenarios. As for downsides, we have quite a few. It doesn't have a search or filters for requests. You need to keep the inspector active. It can't repeat requests or copy them as a cure command. QA engineers should learn how to use Android Studio as well. In conclusion, the native Network Inspector tool will cover all the basic needs of network profiling. It is sufficient enough for regular development. The next tool is the OkHttp Logging Interceptor. It's a simple tool that allows you to see network requests in Logcat. We can open Google and search for the first references of OkHttp Logging Interceptor. Just type it and press the first link and we will see GitHub of Logging Interceptor. It has some documentation and also it has a Gradle implementation for us. Let's edit and then press sync. After we can go to the main activity and search for OkHttp client and apply something to it. In my case, I'm doing everything for debug configuration of the build, so we can just write if build config.debug. Then we need to create HTTP Logging Interceptor and set the log level. For the first case, I will set it as basic. Next is create a local variable and set it to the OkHttp client with add interceptor methods. After it, we can run the project and see the output in logcat. Let's make some calls, and we can clearly see that we have a GET request here and we have a response with code 200. The output has OkHttp tag prefix. We can filter it and see the results only for it. And we can change log level from basic to body, and we will see the body of request and response in our logcat. Let's set body, let's run, and let's make another call. And here we see this body in logcat. Same hash map with lists of integers. Additionally, we can see headers on top of the body. The last experiment is to set log level as headers. We can see that only headers appears in the logcat. Next, I'll encapsulate this logic to the separate method, and let's talk about pros and cons. The upsides of the HTTP Logging Interceptor are the same maintainers as the OkHttp client. The library is lightweight and easy to add. A developer can filter requests in the logcat. Different log levels for different types. On the other side, we have downsides. Non-user-friendly look. There is no UI at all. It's harder to navigate through huge responses. Inability to copy the body of the request. The logcat becomes too chatty. Inability to change requests and responses. In conclusion, this type of network inspection will suit small investigation or a huge fun for reading logs. It's not as dev-friendly as the rest of the tools. Let's move on to the next instrument. OkHttpProfiler. It's a plugin for Android Studio, so we need to open Android Studio settings and search for plugins. We can select plugins and type OkHttpProfiler and press search in Marketplace if it doesn't appear in the list. After installation, Android Studio will ask us to reboot it, so we will press Restart IDE and wait a bit for a new window. After, we can go to View tool window and search for OkHttpProfiler, or we can press double shift and type in OkHttp in this window and open OkHttpProfiler from that. Now we can see installation instructions, and we can copy implementation of the plugin and paste it into build.gradle file and press Sync Now. Meanwhile, we can go to main activity and add this interceptor to the OkHttp client. We can copy it for build-config.debug only to avoid releasing this plugin in production. And we can add interceptor here. Just type add interceptor and OkHttpProfiler. After the Gradle sync, the file will appear in the imports. And that's it for installation. Now we can run the project and see it in action. Make some calls, and we can see them in the tool window. We can see get requests for colors file. OkHttpProfiler has some tabs. The first one is raw request. It will have headers and request by itself and request body if it has. The second one is raw response. Same headers, response code, URL and body. The third one contains only headers. And the fourth one has a tree. The body is a JSON tree. It's pretty useful when we have huge JSON models and we can navigate through them, minimizing and maximizing some nodes. The last tab is response formatted. We can see a formatted response body here. Another useful feature is that you can copy a request as curl command. You can send it to anyone and they can execute it in command line. Additionally, OkHttpProfiler prints all the request and body and headers in the logcat. Another important feature is that you can create a JSON model directly from the plugin. You can use the menu and click and it will create a file with all serialization names that you require. Now let's speak about upsides and downsides. It has the detailed list of requests sorted by time. You can explore the JSON as a tree or as a plain text. It auto-creates a Kotlin or Java model for the JSON parser. The library is lightweight and it's easy to edit. On the other hand, you have to add a third-party library to the project. The logcat also becomes too chatty. It cannot repeat or change requests or responses. It could be slow on a huge amount of data, like pictures or huge JSON. In conclusion, OkHttpProfiler is a nice tool for network inspection. It can cover all basic needs and it can fit for regular development. The next tool is Charles Proxy. To install it, we need to visit charlesproxy.com and download it and set up for your laptop. After, we need to go to res folder and create new XML called network security config. Then we can delete content of this file and paste the following lines. You can find them in my repository. It will allow the application to use a custom certificate that we are going to install next. Finally, we should add this network security config into the application in the Android manifest. That's all changes for our codebase. Now we can run the application and go to the system setup. Let's open the notification bar and make a long press on the internet. It will open the settings of it, and we can choose settings of Android Wi-Fi. Now we can press pencil and select proxy. Like manual proxy, we need to type 10.0.2.2 and port 8888. Now we can press save and minimize these settings. Next, we need to open a web browser and then go to the Charles Proxy application. Then press Help menu and select SSL Proxy. After, we need to choose Charles Root Certificate Help. On the very bottom of this, you can find Charles Proxy URL that will allow us to download the certificate. So we can paste it in the web browser and the certificate will be downloaded automatically. Finally, we need to go to the system settings and search for certificate. Let's just type in it. We can choose CA certificate again and install anyway. After, let's press on downloaded certificate and it will be installed in a moment. The Android part is done. We can close everything and go back to our main application. We can go to main activity and copy our hostname. Then open Charles, proxy menu and SSL proxy settings. Let's add a host here and then press OK and OK again. Now, finally, it's ready to go. We can open our application and make several HTTP requests, then go back to the Charles proxy and we can see them here. This application can show the request and response in different way. It has overview section or content section with a tree or summary section or charts or notes. Apart from it, you can see JSON text, JSON tree, raw data, or hex data or text. Not only is it the inspection tool, but it also can make a lot of cool stuff, like repeating requests, like adjusting them, or changing the request or response code or body. It will take a lot of time to review all the features of this application, and it's not a topic of this video. You can do it yourself or use Google or whatever. And we will briefly summarize pros and cons next. The upsides are: we can see all traffic from the device, not just the Android application. We can see JSON and other data in comfortable ways like a tree or plain text. We can change network parameters, enable throttling, change the network speed, etc. We can resend or edit any requests. We can debug WebSockets or sockets data. And the downsides are: not so easy to install and configure. The charge is not free, it costs approximately $50. If you enable a proxy on the device, it will work only when the charge is open. The Charge Up window is not integrated into the Android Studio. That's it for Charles. Let's move on to the next tool. Flipper from Meta Company. At first, we need to go to fbflipper.com and download the application. And don't forget to support Ukraine. Then we can go to Setup page and choose Android with Gradle. After, let's copy dependencies and put them into build Gradle of our model. Let's open build Gradle, let's paste it there, and change a bit view to match Kotlin standards. After, we can press sync. Next, let's create a new file and encapsulate the logic of Flipper there. Let's make it an object and name it Flipper. It will be a singleton class and it will hold all needed references. Let's create init function with context as a parameter and paste here initialization logic from fbflipper.com. Let's go there, copy these lines of code and go back to Android Studio and paste it there. After, we should fix imports and replace context variables where it's needed. To use Flipper, we're required to have a custom application. We don't have it in our project, so let's create it. Let's create a file main application. Let's extend it from regular application and use onCreate method of it. We can call flipper.init and pass this application. Next, let's go back to fbflipper and scroll down a bit and find network plugin setup. We can copy dependency and paste it in our build.gradle and fix it a bit. And sync the project. We can go back to fbflipper and search for network flipper plugin. It will be required to activate network. We can copy it, go back to Android Studio and paste into Flipper. Let's open Flipper and paste it as a variable. Yeah, it's ready and we can add it to a client here in initialization methods. After, we can go to main activity and add the interceptor to OkHttpProfiler. In real application, it should be done somewhere in the dependency injection library. But in our case, I don't want to overcomplicate this example. I forgot one important thing is to add application into Android manifest. So let's open it and add a name main application there. Finally, we can run a build and open Flipper application on our laptop. After the start, we can see that it has logs and crash report only, and the network is unavailable. We can choose our application and enable the plugin after. Let's go back to application, press several times on make HTTP request, and now we can see it in the Flipper application. We can see body and we can see same headers as we saw in previous tools. In Flipper, we also can copy a request as curl command. We can make some filters and copy some information. I would say that the Flipper application is not only about network. It also has logs and we can review everything here. And it has a crash report here. and CPU or database or other plugins that can help debug and improve app performance in general. It's time to pros and cons. For positives, I can only say that the tool is meant to replace Firebase as a complex solution for network, CPU, crashes, database, and etc. However, I see a lot of negatives. It adds a lot of debris into the application, native C libraries, clients, and rest. The app shares a lot of data with a meta company, logcat, crashes, database. The app has a version 0. something, which means it's still a pilot rather than a release. The app seems to be heavy and deeply integrated into your project. It doesn't integrate into the Android Studio. In conclusion, I can say that the library is more of an app performance profiler tool rather than a network inspector. It can somewhat replace native Android Studio instruments, but it's definitely not just about the network. The next tool is Proxyman. We need to go to proxyman.io and download a Proxyman for your operational system. Next, let's open the application and go to Certificate menu, Certificate on Android, and choose Emulators. First step, we need to install a root Proxyman certificate, and then there is a trick. It's written in the documentation that Proxyman doesn't support emulators with Google Play Store. In my case, I need to create another emulator without Google Play services. I'll use a device manager and add another device without Google Play Store. I will use Pixel 6 Pro with 34 Android on a board. Let's start it and close the previous emulator. Next, I'll run the application and go to the Proxyman application. It has Override Emulator button, we can press it and it will do some tricks under the hood. In the same way as the Charles Proxy application, this application requires some network security config in the Android application. Apart from debug overrides, it has a section with base config that allows clear text traffic. It doesn't make a lot of sense to me to add it to the production application. So we should go back to the Android Studio, res folder, XML folder, and network security config file. Then in the bottom of it, we should add this configuration from the help. I want to emphasize that allowing clear text traffic in the production application could be a security issue. I would highly suggest to reconsider adding these lines in your project. We already know that we are using this network security config in the app manifest, but if you are adding this library from scratch, you should open Android manifest and check if it uses there. Next, we can run the application and make several requests. Let's open Postman and see that we have this domain in the bottom of the list. The next step is to enable the response for this domain. We can enable it, go back to the application and press Make Request. After, we will see request and response here in a parsed way. We can see headers, we can see body, we also can see it raw, or very convenient way is a tree for JSON. Traditionally, we have upsides. We can see all traffic from the device, not just the Android application. We can see JSON and other data in comfortable ways like a tree or plain text. We can change the network parameters, enable throttling, change the network speed, and etc. We can send, resend, or edit any request. We can debug WebSockets or socket data. And for downsides we have: it doesn't support emulators with Google Play services. It requires allowing clear text traffic that could raise security concerns. It's not so easy to install and configure it. Proxyman costs approximately $50. If you enable a proxy on the device, it will work only when the Proxyman is open and the Proxyman is not integrated into the Android Studio. The Checker application. If we Google Checker Android, we will find this GitHub. It has documentation and we can copy dependencies from it and paste it into the build.gradle of our model. Traditionally, we need to fix dependencies and add brackets. Next, we can open main activity and add Checker Interceptor to our OkHttp client. To avoid memory leak, we will use application context. In the latest versions of Android, developers introduced a push notifications permission. It's required to have it for Checker, so we should add it to Android manifest as well. And we should go to main activity and add code that will request runtime permissions from the user. Let's write a custom method for it and check if a user already granted the permission. We can use context compat for it and check self-permission method. If the result is not equals to permission granted, we need to use request permission method and set Android manifest permissions post notification to it. We can use random request codes, and also we should not forget to limit permission requests to devices that older than tiramisu. And that's it. We can run our application. Let's minimize it. Yeah, definitely we need to allow permissions. Let's make some requests and see notification tray. We can open Checker and we can see all requests there. We can click on any request and we will see details. Overview, request and response with header and body. Also, we can save the request or we can share it as a cure command or as a file. Basically, that's it for Checker. Let's discuss the upsides. It doesn't require a laptop to review requests. It's easy to use it even in the pub. We can copy the request and send it to a backend team. However, the downsides are: it's hard to copy something from the response or headers. It doesn't have a JSON as a tree. It can't rewrite request or response. We need to minimize the application if you want to see a request. We have more space on the laptop in comparison to the phone screen. That's all for today. We have looked at the main tools for checking Android networks today. There are others, but they are not as common. Pick the one that suits your needs. My personal preference for a single use is the Android Studio Network Inspector. For regular checks, I use OkHttpProfiler, and for tough problems, I go with Charles. If this video helps, please like and subscribe. Thanks for watching.